Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says generate permutation of an array. We are given an array ARR of unique elements, so we need to generate all the possible permutation of that element in an array. So you can return the permutation in any order. The driver code will print them in sorted order. That's what is written. So as you can see, we have 1, 2, 3, and here are all the possible permutation, namely 6 permutations. How can we deal with this? So you see, we have at any given point we have 3. Let's say we have n is equal to 3 with 3 elements a, b, and c. So what we can have is we can have 2 sets. Okay, right now whatever constant set I'm having and whatever pool I can check into. So I can consider this as fixed and I can consider this as pool. Right now when we are starting, we don't have anything fixed. We have A, B and C within picture, and we can take either of them element from this. So either we can go with A, or we can choose B, or we can choose C initially. So anything is fine, you can go with anything. I'll do in quick level of starting with A. So I'm taking A, fixing B and C. Fixing A and having a pool of B and C. Likewise, I can take B next, having a pool of C, or else I can take C, having a B as empty. So yeah, could do that, and it would give me A, B, C, A, C, B, and yeah, in this way I can get my fixed element, the number of fixed from, or this line to go from next. So that means I'll have 2 sets. That's interesting. And how can I deal with this? Let me take this one below. Okay, let me reset this one. I guess I have messed it up. Okay, private static, and we want this to be as return type. Cool. Quickly zooming in. Now we have an array A. What we wanted to do is we wanted to code it out in such a way that we can get all the possible permutation. That means we wanted to have a result of this type. So this would be our result, new array list, and yeah. So this would be the result, return is. But somewhere between this, we wanted to permute with this A and this result to be as a reservoir where we can store our answers. Also, we can do one thing. We can initiate this right from the start. Initiation is nothing but a starting of that point where we wanted to fix the elements. Initially, I am going with 0 because nothing is fixed. This 0 can later upon go into 1 and say, hey, 1 item is fixed, 2 item is fixed, and so on. So I can go ahead and quickly write this as static permute with A, fixed, and a result. A better formatting can be like this. Yeah. So yes, now it's challenge for us. How can we go ahead? First of all, this fixed cannot be equal to a dot length. If this is equal, we don't have any other option. So no option. let's store it as it is. This will dot add the current list. What is the list? Current list, you may ask. The current list is nothing but whatever elements which I'm seeing currently within a array. New array list. So for int I in a list dot add I. So this would be my current list, and I don't want it to proceed further, so return right from here. Now what if I have fixed elements? What if I have certain things fixed? I wanted to move forward. I wanted to take fixed from till the end of array. So to do this, I'll use a for loop. I'll take an iterator I, which will go from fixed till the end of list, less than a dot length I++. And in this point, I would check that hey, the item at fixed can be substituted with item at I. So can I take this item? So what I mean here is, can I take this item A and substitute with B and get an element such, or get a state something like B A C? Yes, I can do that. In fact, I wanted to do that. So what I can do here is swap A with I and fixed item. Cool. I can just go ahead and create a swap method which would look like this. And what I can do is, once I substituted, I wanted to check for the permutation. So now I have substituted. I have fixed from 0, I have fixed 1. I wanted to go and check this 3 and 4. Sorry, 2 and 3. So what I will to do is permute the next sets. The next set is nothing but start plus 1, or the where we have fixed earlier. So fixed plus 1 with the result as well. And once we are returning back, we would say that hey, you have substituted A with B. Do you want it to continue, or do you want it to substitute back? If we didn't reverse our process, we would end up into illegal states. Illegal states, what do I mean with that? So let's take an example where I have substituted, let's take B and C. And if I'm not changing B and C again, I would still remain in that set B and C. So this would repeat again and again. So that's the reason I don't want that. So I have this I and fixed. Cool. That's it for now. It looks good. It should work. So let's compile this one. Okay, it's void because it's not returning anything. A dot length. Oh, typo. Cool. It worked with the sample test case. Let's see what happens when we don't have this. So you see, it will keep carrying out the previous state. Yeah, it kept carrying out the previous state, and we didn't had anything or any element where we had 2 as a starting element. So like this. So it just ignored the fact that hey, we have substituted 1 and 2, but it just went ahead. Why 3 got substituted? But because 1 and 2 already swapped, we never reswapped. Next there was a turn of 3, and 3 and 1 swapped again. So if there were few elements, 3 would be the repeating elements until and unless we have yet more another elements from 3. So that's the reason we have to have set this back again. Let's submit this one to check whether this solution works for rest of the test cases as well. And yes, it does. Yes, it does. And that is something which we respected the time and space complexities as well. And topics as always, recursion and backtracking. So backtracking, where we just backtrack it and fix out what all changes we did. This step is the backtracking one. And this was all about it. For more such awesome content, click the video on your right and I'll see you in the next one.